So points on a unit circle. The directions here say show that the point square root of 22 over 5 and square root of 3 over 5 is on the unit circle. So basically, if you understand what a unit circle is, it's basically a circle so that all the radiuses, or all the radii, have a length of 1. So that length right there would be 1. If I made another radius right here, that length would be 1. So again, that's a unit circle because the radius all around that is going to always wind up being 1. And to prove that, you have to understand this. If I looked at this circle, I have a length here, I have a length there. This would be my length in my x direction. This would be my length in the y direction. So when I look at this point, that point will be the x value and the y value. Basically kind of like the rise and run, if you think about it as a slope, or it would be two sides to the right triangle. All right, so x and y are the two sides to the right triangle. Where x represents the horizontal distance and y represents the vertical distance. And also that hypotenuse there and that radius is also always going to be 1. So if I wanted to prove that, I could use Pythagorean right then, and I could simply say, well, x squared plus y squared has to equal to 1 squared. So if you want to prove that both of those lengths have to be a and b in the Pythagorean theorem, so it would be a squared plus b squared equals y squared equals 1 squared, or x squared plus y squared equals 1 squared. So since x is the square root of 22 over 5, you're going to square that. And then the y value is going to wind up being the square root of 3 over 5. It's going to be plus the square root of 3 over 5. You have to square it. And then, of course, the last number is 1, so it's equal to 1. So when you square a fraction, you really wind up squaring the top and squaring the bottom. So when you square that, that's going to be the square root of 22 squared over 5 squared, and that's going to be plus the square root of 3 squared over 5 squared. It's going to equal to 1. So when you actually square the square root of 22, you actually get the radical from being around it. So when you square the square root of 22, it's just 22. Of course, this is going to be 25. When you square the square root of 3, it's just going to be 3. And that's going to be 25. And it's going to equal to 1. All right, because 1 squared is going to be 1. So on top, we should wind up having 22 divided by 25 plus 3 divided by 25 equals to 1. So if that's the case, when I combine those fractions and they both have the same denominator, 25 and 25, I can add the numerator straight across. So I wind up having 22 plus 3 divided by 25 equals to 1. And that basically is 25 divided by 25 equals to 1. So I get 1 equals 1. So basically that's a proof that ordered pair has to be on the unit circle, because when I check it out, I actually square those using Pythagorean theorem, I get 1 equals 1, meaning that's a true statement. If I had something different like 1.5 equals to 1, or 0 equals 1, or anything other than 1 equals to 1, it would not be a true statement and it would not be on the unit circle. So this is the proof that ordered pair is actually on the unit circle.